Hi, my name is Cody. I'm a software engineer here in San Francisco. In this video series, we are building an AI coding agent from scratch using LangGraph. In the last video, we refactored our agent to use a little bit of a simpler architecture. And what we did was, our old architecture was this kind of very kind of basic generic workflow, which wasn't really actually that agentic. And we refactored it to basically use a simpler structure where rather than creating all of these different nodes and branches and conditional logic, we made it just a much simpler looping pattern where we have a software developer assistant and then we give it a handful of tools that it can use and where the LLM can make decisions to do what's called a tool call. Then we gave it 3 tools. One was to write HTML, which would write HTML code to a file. The LLM would provide this input parameter and then our agent would call it. The second tool call was to write CSS, where it would provide, the LLM would kind of shape the output from the LLM to match this signature with this input argument, which was CSS code. And the third one was to write JavaScript. Then the LLM will make those tool calls. We pulled in our pre-built tool node from LangGraph, which automatically then executes the tool call if the LLM decides that that's the tool that it should run. In this video, what we're going to be adding on top of this now is actually something that's called a checkpointer. And what this provides us is it provides us memory for our large language model so that it understands the previous messages that was sent back and forth between the user and the coding agent. I'm going to give you a brief demonstration of what this looks like without memory persistence. But one way to think about this is that the large language model does not remember the chat conversation history by default. You actually have to pass this into the large language model on every single call that we give it, and you basically give it a chain of messages that are back and forth from the user and the large language model so that it understands the context of the information on every single API call. Now, I've already been working a little bit ahead, so what I'm going to do is I'm just going to pull up our old code. And what we had before was our agent would just create a workflow and then we would stream the graph information in the agent thought process back to the user in real time. Let's go ahead and just run this old way of doing things so we can see how it works and I can kind of show you the short-term memory loss our agent suffers from. Okay, so let's go ahead and open up our application here. Let's go to localhost 8000/chat. Okay, we're gonna say my name is Cody and my favorite animal is the giraffe. Okay, it's thinking. Let's go ahead and watch this. Now with our latest changes where we refactored it to be a React agent that's using this assistant and tool calling architecture, it actually did slightly break our user experience. If you hide these processing details, it still shows some of this, but it doesn't show like, oh, it's funny. It actually wrote our page to the. Okay, let's try this. Hi, can you hear me? Okay, so that says, hi there, yes, I can hear you. How can I assist you today? Now if I were to say, remember this detail. My name is Cody and my favorite animal is the giraffe. Okay, hopefully it doesn't write HTML. Okay, there we go. Got it, Cody. I'll remember your name is Cody and your favorite animal is the giraffe. Now I'm just gonna say, what's your favorite, or what's the best movie in 2023 as far as your knowledge? I'm just gonna ask it some other completely random question, just to. Okay, so he's answering some question. Oppenheimer, that's a good one. Some other ones. All right, Okay. Now let's try this. What is my name? Let's see if it can do it. I'm not sure what your name is. I don't have that information. What should I call you? And so it just has no idea. I mean, I literally just told it what my name was, right? My name is Cody. And we think we take some of this stuff for granted because it just works out of the box when we're using something like ChatGPT or Claude, right? But that's not like actually how it works under the hood. And when you're using the API, it doesn't actually remember that. And the way to fix this, well, there's a couple options. One of them is that you could just go in and manually like kind of copy out this information and say, you know, previous conversation, right? Like this. And then you could paste in the contents of the last thing. And then you could say, you know, user message, what is my name? User message, like that. This is one way you could solve it, right? Now the user doesn't have to do it, right? And then now it knows your name is Cody. The user wouldn't have to copy and paste this out because we could actually set this in the system prompt, or we could set this in, you know, you could kind of append it to the message or the prompt that we send in every single time. And you could take the history of the conversation and throw it into the prompt for the next time you send it. And this is essentially this is essentially how everything works. This is like, you know, if you boil it down to its essence, this is how it works with every single platform. Is you are passing back in the context from the previous conversation into the large language model and telling it this is your conversation leading up to this point. So, you know, we could make a database table and we could write the information out to that, or we could make like a JSON file or a TXT file and just kind of every time the user sends a message, we could just write that to the file system, and then we could, you know, when we go to send the next message, we just load the information out of the file system and append it into the prompt. That's one way that you could do it. And in fact, there's a lot of applications that actually work like this, where I've seen people's implementations of it, and they'll just save the chat messages out into a database table, and then they'll send it back into the prompt on every subsequent call. But if you're using LangGraph, there's actually something that they have built in automatically, and it's really, really simple to implement. And essentially what you do is when you're creating the LangGraph object, you can actually come up here and you can set a thread ID, and then you can pass in a config file to the graph when you're creating it, where you give it a specific thread ID. And out of the box, LangGraph will actually save this information to your file system, and it will start to remember those conversations by as simple of an implementation as this. So there is one more thing you actually have to do, which is you need to come up and you would import something like this, langgraph.checkpoint.memory, and you'd import this memory saver object. And then in here, you could just go and say checkpointer, I'm going to call this checkpointer2 equals memory saver. Then you take this checkpointer 2, and when you're building the workflow, you can say checkpointer equals and then the variable of the checkpointer. And this will actually just save the information to your local computer's memory. So let's go ahead and try this now. So let's go back to our page here. Let's refresh this page. Let's say, please remember this fact. My name is John. Let's try this. Okay, let's send this in. Got it, John, I'll remember that. Now let's say, what year is it? Let's see if it can get this question right. Sometimes it will funnily say, oh, look at that. The current year is 2023. All right, well, that's funny. All right, well, let's say this now. What's my name? Let's see if this works. Ah, it did not work. All right, let's try turning our server off and turning it back on. Let's try this one more time. My name is Kelly. Watch it write HTML. Oh, there we go. Okay. What's your name? I'm ChatGPT. Okay. What's my name? Okay. So a little bit of a issue here. So I got this example from the LangChain Academy course, and they're actually doing this in a Jupyter notebook. And so the this memory object actually only gets saved on the stack when you're running the program. So in fact, it doesn't actually save the memory. Well, it does, but it doesn't like write it to the file system. So like I thought it did. So what it actually does, let me just show you. So what we can actually do is we're just gonna up here in the global namespace, we're just gonna say let's call this memory checkpointer equals memory saver. So what we're gonna do is we're gonna initialize this as a global variable that will persist as long as the fast API server is running. So let's do that, and then let's go ahead and change this to be memory checkpointer. Let's go ahead and stop the server. Let's refresh it. And then let's try this one more time. Okay, let me move this window to the right place, move this one back. Okay, bring this one here, come here, let's refresh. Okay, remember this fact. My name is Jeff. Okay, understood, Jeff, I'll remember that. Okay, what's your name? Okay. Already it's saying, how can I help you today, Jeff? Let's say, what's my name? I think it remembers. So that's kind of how it works. Now this memory saver, the problem is if our server ever turns off, then poof, this goes away, right? So LangGraph has a bunch of different ways that you can actually save this. Their memory saver is just the one that saves it in memory, like in your actual computer's RAM while you're running locally. But they have a bunch of different checkpointers. So we can actually look up here. Let's look up LangChain checkpointers. So they have this whole guide on persistence. And they have these different ways that we can basically save the information out. So one of them is this memory saver. It looks like they might have changed this recently to be in-memory saver, which is actually a much clearer name. Let's see, that's memory saver, but they also have good ones for like SQLite. If we look up SQLite, if you have a SQLite database, you can actually configure this in LangGraph to where it will persist these checkpoints to the SQLite database that you have. And this is really great for running something locally. Now, if you are running something in production, they recommend that you use the PostgreSQL checkpointer class. And but what this would require though is that you actually have a Postgres instance running on your server or on your local computer if you're testing with it in order to get that same benefit of persistence. There are some other ones. I think they have like a JSON serializer. So you could basically have it serialize out JSON, and then you could like write it to your file system and then kind of load it back and forth that way. But the one that we're actually going to roll with for the bulk of this project is we actually are going to use Postgres. And there's a couple of reasons why I want to do that. One is Postgres is pretty widely accepted and understood as a very high quality open source database. It's very feature rich with so much that you can do. And one of the features that I really care about is as we build out LlamaBot, there will be a point where we want to allow our agent to handle text embeddings. And essentially this is going to be retrieval augmented generation, RAG, where we are going to want to have the capability to upload really large files, maybe thousands of pages worth of documents, and have those files be chunked and indexed and embedded so that our large language model in the future can search through those files in order to accurately pull out information that's relevant to the user query. And Postgres has a very great extension called PG Vector that can save these text embeddings. And what will be really nice is we can have the same database that handles our persistence and our chat messages. We can have the same database hold all of our text embeddings. So that means it's one less application to actually set up. The other benefit is we can actually configure that same Postgres database with a library called SQL Alchemy, which is basically an object relational mapper, so that we can get nicely formatted Python classes and Python objects mapped to our database tables. And in the future, we can actually have our large language model create new data structures and new tables in our database that might be relevant for long-term kind of database persistence on the application level. So there's a lot of benefits. Like if we just use Postgres, then from the beginning, then we get a lot of benefits. And one alternative we could potentially consider is something like SQLite. The biggest problem with SQLite though is it doesn't really have a strong vector embedding support. I know that they have made some strides with that recently, and there actually are some tools where you can save text embeddings into a SQLite database. But SQLite is just definitely a little bit for kind of smaller toy projects, and we want the apps that we're building to eventually be deployable and make it so that we have all the benefits and feature richness that comes from using something like Postgres. So we're going to roll with Postgres. It does complicate a couple of things, such as deployment and even developer, like when you first pull down the repo and you want to just go quick. So the other thing we're going to do in a future video is we're going to wrap it all up into a Docker container so that the developer can pull the project down very quickly. And then the other benefit of using a Docker container is that we can actually make it very simple to deploy our LlamaBot applications into production when we're ready. We can use a service like Fly.io or Railway. I also know that there's some really great tools that we could even launch our own AWS EC2 or Lightcell instances, or even the Google Cloud has a really great suite of tools that we could do to very quickly deploy these containers out into the wild, and it just will drastically simplify how we do things. So there's a lot of benefits of doing it this way. That being said, I'm going to go ahead and dive right into the implementation here. So like I said, I was already working on this a little bit earlier. So what we're going to do, so I'm going to pull up kind of our code changes here, and let's get rid of this memory checkpointer because we actually aren't going to use that. And then we're going to use, there's actually a library called PostgreSQL, and it's, if the pip package here is, I think it's LangChain. What is it? Like LangChain checkpoint should have everything that we need. It should have Postgres, it should have memory and all those other things. Let's go ahead and scroll down here. The other thing that we need to do is we need to set up a Postgres database and get a connection URL. If you already have a Postgres database set up, that's great. And there's a couple of commands that we need to run in order to make this work. In case you need the commands to set up a Postgres database, let me just pull some of those commands up here. So what we can do is basically you would go onto PSQL using your command line tools. I think the command is just something like, you just go like PSQL, and then you would be able to paste these commands in: create database, create user, grant all privileges. This is just a local development password for Postgres. We wouldn't actually deploy it with the same password. We'll change that. And then from there, you should be able to get your connection string, and then we can add it into our llama.bot.env file. There's some other commands that you're going to need to run so that LangGraph can set up the tables that it needs to in order to basically configure the checkpoints. Let's go ahead and jump back into our code here. So there's this DB URI. In fact, what we're going to do is we're actually going to load this from our environment. DB URI equals os.getEnv DB URI. I'm going to go ahead and add this into our env example here. Env example. So what we're going to do, we're going to add this in here. I'll go ahead and add it into my real env file as well. Okay. Let's go ahead and jump into our app here. Awesome. Okay, our checkpointer. So now we need to, I'm going to get rid of this Postgres flag here. I was playing around with some stuff earlier. Let's come into here. Okay. Awesome. DB URI as checkpointer. I'm going to go ahead and rename this. Let's call this PG checkpointer for Postgres. Okay, awesome. And then there is something that you have to run on the very first setup that you do. You need to basically call this .setup function, and this will actually run the database commands to create the LangGraph tables that we need to. So let's go ahead and run this code. I'm going to go ahead and set a new thread ID. Let's do this to be thread ID 5. Okay, let's go ahead and kill our server and start it again. Oh, that's the wrong one. Let's go over here. Okay. Let's refresh this. Let's say, what is my name? Which I shouldn't know the answer to this question, right? Because we haven't told it yet. I'm not sure what your name is. Okay. I'm gonna say, please call me Sir Jamie. Let's try that. Certainly, Sir Jamie. How can I assist you today? Okay, great. And I'll say, what is pi times pi? Very cool. What is my name? Your name is Sir Jamie. Awesome. Now, one of the cool benefits of running Postgres locally and doing it this way is we can actually come into our Postgres database here and take a look under the hood as to what LangGraph is actually saving. So we have this LangGraph-dev or _dev table. Let's go and look at our schemas here. And this should tell us our tables, which there's 4 tables it adds: checkpoints, checkpoint writes, checkpoint migrations, and checkpoint blobs. Checkpoints is the one that actually saves the information that we're looking for. And if we query out the last, let's just do 100 rows, or the first 100 rows, then you can see that it's actually saving a database entry with this thread ID as the primary key that is a text column on every single run. And so that's how it actually persists the memory. And one of the other things that, from here, I mean, they have like this entire implementation. It actually saves out quite a lot of information for each run. It's not just the user messages that get saved out. It actually saves out every single node step in between. And this means that when our large language model, when our agent actually runs, it doesn't just save the user messages, it saves the internal state of our graph at every single step, which means that we can go back in time and actually inspect and debug our agent pretty much no matter what, as well as provide other information. And one of the other cool benefits of this is that we can actually, using LangGraph, using their SDK, we can actually query these checkpoints out and display them. So I added this new route called chat history / thread ID, and this basically will just return a JSON object of this thread ID. So basically what we do is we load our database URI again. Let's go ahead and just change this to be pulling it from our file here. And we create a PG checkpointer right here. Okay. And then what we're going to do is from here, we do that exact same config and we actually build the graph all over again. And then there's this cool helper function method that's just called getState, and you pass in the config and it'll actually get you the last state snapshot object. So let's go ahead and just inspect what this object looks like. So what we're going to do is let's go back to our page here. And I think, what was this called? Chat message or chat history / thread ID. So let's go back into this. And then the thread ID that we gave it was 5. Okay, let's go ahead and toggle pretty print. And now you can see we have the entire contents of the message in here. Content, what is my name? I'm not sure what your name is. What would you like me to call you? Please call me Sir Jamie. And so here we get to really closely kind of inspect the message objects under the hood. You see that this one shows that it's a type human. This one shows that it's type AI. And then if we were to do something else, like tell it to please create an arcade game of Sir Jamie riding on a horse and getting a high score, I don't know, something like that, then let's go ahead and just see what this comes up with. I mean, this should actually write HTML, write CSS, write JavaScript, right? It should trigger those tool calls. Here we go. There we go. Tools. HTML code written to page.html, written to page.css. And what's cool with LangGraph is we'll actually save each of these tool calls as a message in that message state. And so then when we go to, in fact, I wonder, let's refresh this. Oh, you know what? We're mid-run, so the server's blocking right now. Oh yeah, look at that. All right, there's Sir Jamie with his lance thing, right? He's jumping over cactuses or something. Or he's jumping over stable boys. Something like that, right? Okay, cool. Okay, so now let's go ahead and refresh our chat history, make sure we're looking at the right thread ID. Okay, and then now if we come down here, yeah, here we go. Now we can actually see tool calls and inspect tool calls coming back in real time. And this is just a very nice kind of persistence thing. So now in the future, if we were to then ask the question, how did you implement the character, I don't know, the character view / look, then it should be able to actually look back into the message thread. Yeah, right here in the horse.draw routine inside assets visual, I did this, blah, 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 right? Can you please overwrite this JavaScript to draw something that looks more like a horse? Let's try this. And I think in this case, it should make the right decision to just modify the JavaScript. I don't think it will go and modify CSS or modify HTML. But I could be wrong, depending on how it implemented this. Yeah, page.js. I'm pretty sure this will just modify the JavaScript. It's going to tell us. You can see it streaming right here in the background. Yeah, JavaScript written to, there we go, look at that. Okay, so that's cool. So it made the decision to only override the JavaScript code. This is one of the advantages of doing the tool calling the way we were doing it, where now we're using tool calling. And like again, if you were, we talked about this in the last videos, but if you were to go back and try to implement it to just change the HTML using this old approach, you'd have to make explicitly new nodes, new prompts, new instructions, telling it only go and change the JavaScript, right? So this is a little bit of a way to route the behavior. If we were to tell it to, invert all the colors, then I think that we could probably get away with it just writing to the CSS. Maybe it would need to overwrite JavaScript too, I don't know. But anyways, that is how we implement persistence. Now the only problem is, now if you're a developer, that does mean that you have to have a Postgres database set up properly if you want this to run. So what I'm going to do is in the next video, we're going to set up a Docker container that can house everything in this very, very quickly. Hopefully that'll make a little bit of a user, improve the developer experience when you're creating this. It does make a new dependency on Docker, but that's pretty standard across projects. But it also gives us some good unlocks, like it will allow us to deploy this easier. It allows us to bring vector storage into our project, which LangGraph has some really great, LangGraph has some really great libraries to do that as well. And in general, just make our agent more solid, more stable, ready to take on more of what we're wanting to throw at it. So I hope this was helpful and useful to kind of document the thought process that we're going under as we're building this agent out. And I'm going to go ahead and get a nice little shot for our YouTube caption here. Let's go ahead and play this game a little bit. Okay, kind of fun. All right. Cool. And next video, we're going to set up Docker. So I'll see you there. Thanks.